Welcome, everyone. Make yourself at home comfortable. I'm Michael Littlecrow. I'll be your instructor for Math 171 this semester. Be kind to me this first day. I've been in Thailand for 3 months over the summer. I think my body got back here, but my spirit's still somewhere halfway over the Pacific Ocean. So I woke up at 4 this. My sleeping is still not there, so I feel like I'm ready to go back to sleep now. But we'll get through it. So fortunately, this is my last class for today. So I had a 7:30 class, and then I've got this one. Typically, you'll see I'll go over the schedule, but then I'll have office hours right after this class. My office is over in ECA, Engineering Center building. So we'll see how things work out, but if you need some assistance during office hours, maybe what we'll do is we could set up over here. We don't necessarily have to go back there, but we'll work through that. Today I need to leave right after class. I'm doing a project with AP Pre-Calculus. How many of you have taken an AP class in high school? Awesome. So there's now AP Pre-Calculus, which since I coordinate the online pre-calculus here, I've been involved with this summer. So I did 4 workshops over the summer, the virtual workshops, fortunately. So I was in Thailand, but the workshops were here in the U.S., so I was up all night long and then slept during the day. So anyway, it's pretty good. Anyway, tonight in Chicago, they're having a workshop for the consultants, and I'll go with that. But what it's helped me to see is some of the things that they do there, actually in the high school version, the AP Pre-Calculus. There's a few things we might want to bring in from that we aren't doing here, but we'll do it. So I coordinate the ASU online version of this course that gets taught in 7.5 weeks. You're taking the STEM version, which has 4 credits, so you'll also have a recitation. And in this version, we have this very similar content. However, you will also, in that recitation, get more experience doing some algebraic manipulations. I'm assuming most of you are engineers. How many of you are going into engineering? That's what I thought. And then maybe some science majors? STEM? Yeah, okay, a few of you. I suppose there could be some from any psychology majors? No, okay. So primarily it's a technical part of it. Before I forget, if you're in the Thursday recitation, you don't meet today. So we're going to start recitations next week, so everyone will start, both the Tuesday and the Thursday will start next week. So you're done after this class as well. You don't have the... one of the recitations is like right after this class. I can't remember if it was a Tuesday. Tuesdays is right after this class. And the Thursday's a little bit later. Okay. Something like that. Anyway, you guys will figure it out. Jasmine will be your TA for that. I'll work with her. She'll have worksheets that she'll have you work with, and you'll get a chance to basically talk, and which is one of the most important things for engineers to learn, is not just how to do the math, but how to communicate with their colleagues and build that kind of understanding. So we'll do that. It's my first time teaching this version of the class, so on the technical side, I don't really know how it works, So I've used there's a My Math Lab. I've used that before because that used to be the online version. Also used it, and then we went away from it. So I know the content and such, but again, as far as how everything's going to work technically, we'll work on that together. I do know how to teach. You know how to learn. That's the important thing. All the other things are just details that will get worked out. So where we'll start off with, let's see. Where should I start? Little story. So a little bit more about myself is I've been teaching for 24 years. Before that, I was in financial planning and such. Before that, when I went to school, much like you are, I started as a freshman in pre-calculus. I struggled with math. In fact, actually, I almost dropped out of school because of math, because I'm dyslexic. And I had the good fortune when I went to take calculus the second time. I think I got a C, maybe it was a D. Anyway, it wasn't good enough to get into engineering school. So I took it a second time when I transferred over to Portland State University. By the way, is anyone here from Oregon? Any other Oregonians in the... Not a single one. In my other class, same thing. No one from Oregon. Okay. Well, I've spent about 40 years there. I've been here for 20 years, but still think of Oregon as home. Anyway, so I went to Portland State University, and my first semester there, I got Dr. Crittenton, who the same semester that for Calc 1, he found out he was dyslexic. He never knew what it was. So he spent this time explaining to us what that was and how he sort of thought in circles, and they told him he couldn't read. And he goes, "What? I got my PhD in math. What do you mean I can't read?" And I said, "Well, what you do is not called reading. You pick information off a page." And so he would tell us all these things, and I go, "That's exactly sort of what I do." So I started going to every office hours he had, and the way he thought through math was the way I thought through math. So I found someone that kind of helped me get through. And so, but then I decided, hey, maybe I can help, as he helped me, a struggling person in math, maybe I can help other people in math. So I switched from engineering to math education. My dad wasn't too happy with that, because I didn't tell him like till 6 months later, and he found out something came in the mail and stuff. So I guess talk to your parents first, but I always do things first and ask questions later. So that's kind of my story. So my goal is, I'm an educator first. I'm not really a mathematician. I tried to go that route a little bit, but that's not really what I enjoy teaching. I enjoy helping people understand, and I enjoy working with different types of learning styles and such. So helping you to find out what works best for you. So we're going to go over the syllabus, but let me give you, I didn't write the syllabus. In fact, the person who does coordinate this portion of the course, I've worked well with her. I really appreciate all her input and what she does. But sometimes in the syllabus, they have all this sort of legalistic stuff, and so I didn't write that stuff. She didn't write most of it. We have this stuff like kind of has to be there. So sometimes it's kind of harsh statements. We're really more about kindness and learning and such. So here's so there's all these policies and stuff in there. We'll talk about whatever there. But my rules, I really only have 2 rules for the whole class. And it's based on one concept, is you think about our lives, what do we really own? Now we might think we own our computer. This is my computer. This is my thing. But we really don't, because somebody could take that computer away from us, and now it's not our computer, it's their computer. Somebody stole it, right? Or it breaks, and now it's not my computer, it's broken. But what we do own, though, is our actions. So when we do something, we did it. We sometimes say, I didn't mean to do that, or, I was sleepwalking, whatever. But our actions, we own those. And part of our actions are our thoughts, because usually what we think will turn into what we do. There's 2 types of actions, so these are the 2 rules. There are skillful actions, and there are, what's the opposite of a skillful action?
Unskillful.
There we go. Simple rules, right? We already know this. What is a skillful action? What would you consider to be skillful? An action that's skillful.
Something you've learned and developed, practiced.
Something that helped you, learned you, something that benefits you, right? Skillful. Gets you to where you want to go. So then what would be an unskillful action? The opposite. Kind of holds you back. Something, doesn't get you to where you want to go. You know the difference. And sometimes the same action could be skillful for one of us and unskillful for another one of us. And I give you the example of when you study, maybe listening to music. For some of y'all, that's a good, it helps you study, it helps you focus. That's a good, skillful action. For me, I get rocking into the music and I forget about the studying. And so for me, it's unskillful because it doesn't get me through what I'm trying to do. So those 2 things. Along with that, there's one action that's always, no matter what, considered unskillful. And that's an action that causes harm to ourself or another. If it's causing harm, it's unskillful. Sometimes people do those, they cause harm to others and they get a lot of goods from the world or whatever. But that's still an unskillful action. And so in thinking of this as our way we work through class, what I'm going to ask you to do is just examine your actions. Are they skillful or not? Again, the way you're studying, is it getting you to where you want to go? If it's not, then you can take a look and say, I must have some of these things I'm doing are unskillful, so how can I get away from those? And then how can I work towards being more skillful? So I look at the things that are getting me to where I want to go, and I want to do that more often and do the unskillful less often. So it's not about right or wrong or anything, but working more and more to being skillful and being successful. Okay. But that key part is don't hurt anyone. We don't hurt anyone, we keep trying. But once we hurt somebody, especially ourselves, we don't want to hurt ourselves, right? But we don't want to hurt anybody, causing pain or suffering to someone else, because that's always unskillful. Okay, so those are the two rules I go by. And again, it's not really a rule because what's skillful for you might be unskillful for me and this or that. But it's our in my studies, what one of the theories I hold on to is self-determination theory. Is that that there's 3 psychological needs that we all have. And if we have those, then we're happy, or at least we're more happy than if we don't have them. And one of those is the right to choose for ourselves, autonomy. I get to choose sort of when I do things. So you'll see when I do things, as far as there's some due dates, there's some schedules in here. Those are designed to help you be successful. But when something happens and maybe you can't get something done by a particular due date, I'll work with you because we'll get those done, okay? You'll find it, if you can keep up with the pace of the course, it's going to be easier for you in the long run. But if it doesn't, we want you to still be successful. So we'll work with you on that. And sometimes I do this, and then I forget where I'm even talking about. So what was I talking about just before that? Pacing yourself. Okay, thank you. So pace yourself. We'll get through that. So let's kind of just look through the syllabus. We'll see what's important. There's a lot in there that is just, again, boilerplate policies from the university. And again, we'll put them down. So I do have my office in ECA 339. In the calendar, you'll see I've got some office hours, but what we'll do is we'll kind of leave them open. Let me know if you want to meet during those office hours, and we could meet here just as easily as over there. Like I said, this is my last class here. I have another campus I teach at. I think it starts at noon, but it's like not till September. So we can make those things work. It's got my email. Contact me there. Also, on the email, make sure you have the little in the middle. It's not my middle name. My last name's actually Little Crow. It's 2 words, but 1 name. But sometimes students will leave out that little, and they'll send the email to Michael Crow, and that gets to the president's office. And they've kind of figured out if it's about math, they send it to me, but it might delay your message getting to the right person. Okay, so I've got some office hours. I've also got a class Monday, Wednesday. So I've got some office hours around that time. Yeah, but we'll, just let me know what you need and we'll make it happen. It's a 4-credit class. This is, again, a lot of stuff you could look up. Learning outcomes, we'll just basically do all that. This is the important part. You need to have access to my math lab. So there is instructions somewhere in here with a link. That's in Canvas. Actually, there's a link in Canvas. If you click on that, it'll get you registered for the course. I believe this one is set up that you get 2 weeks of use of the software before you have to pay for it. You can pay right away. I've got a couple different classes, and so sometimes I mix things up, but I think they'll let you get started in it. But that's where we do our homework. Okay, so the way it'll work is we'll come here I'll go over some of the content, some of the sections. You'll then be able to work through those homework problems. You don't have to turn anything in. Basically, as you do the problems, you check the answers, and it turns in, and it records it in the MyMathLab gradebook. And this is a technical part. I will either copy those over, or there's a syncing thing where it will end up in Canvas. Canvas is our official gradebook, so things will get moved over there. Okay. In recitation, you'll be working on some worksheets. Again, I'm kind of nebulous about what goes on over there, but the goal is to get you to get some experience working with paper and pencil on some things, working in small groups and talking with other people through problems. And I'll work with Jasmine on that to make that to be a beneficial time for you as well, of time to help you get prepared for exams and such. The exams we will take in here, and there's a few of those, so let's kind of keep going through here. There's all this information about the MyMathLab. You could purchase the book. They do this. We get a discount for it, so when you sign up that way, you can opt into it. You can also opt out of it if you've got some other way to get access to it. Typically, it would be more expensive. So some people think, oh, I'll just opt out because I don't just want to do everything. But then they find that the other option is more expensive. So it's already been discounted, but maybe you have an access code or something that you can use. That's fine. We do need a graphing calculator for this course. When we start doing things, I'm going to show you a new one that I found online. It's called NumWorks. You can actually download it to a smartphone or a tablet or a computer, and you can use it. They've also, this is the only one I've seen that does this, is the electronic one is also made into an actual handheld calculator that you could then purchase for $99. The thing is during an exam, you can't use your cell phone or the computer version, so you would need to buy the $99 version. But this gives you the chance to test it out to see if it's something that you'd want to use. It's a little bit more user-friendly than the TI-84 calculator, which I've also got a lot of experience with and use. If you've got a TI-84, that's fine. We will make that work for you as well. But we do need a graphing calculator because that is one of the ways we solve problems. I had a colleague of mine, I was going to say he was a good friend, but then we had a falling out, so now we're okay. We don't hate each other anymore. But he was an engineer, and he would always tell us in our department meetings, he says, engineers, they don't want to see all your handwork. They don't want to see all your scratch work. They want you to see that you ran it through a computer. And so that's the idea, is engineering especially. We want the technology to run the things because we know that humans make mistakes on the scratch paper. Mathematicians typically want to see a bunch of scratch work and all that kind of stuff, but engineers, they want to see that it's been run through some technology. So graphing calculators, you're going to need one. The only kind we really can't use for the exams, they cut this out, is if it has CAS, which is Computer Algebra System. And that's because it'll do the factoring for you. I always figured if you figured out how to use those things, you were probably smarter than the computer anyway. So I don't have a problem with it, but the department doesn't allow CAS. And so when you go onto your calculus, there's going to be ones that will check that. So if you have a question, just let me know and we'll work with you on that. This is the sort of schedule, and what you'll see is that we've got two sections we're going to take a look at today, and then each week we've got about 3 sections to take a look at. We've only meet twice a week, right? We meet Tuesdays and Thursdays. We've got recitation as well. What I believe I will do, it may change from week to week, but I'll try to hit it heavier on the Tuesday early in the week, get at least maybe 2 sections done, maybe 3 if some of them are shorter. And then that Thursday, there would only be 1 section and a little bit more time for questions and input. as we go through things. But this is sort of the pacing schedule we've got. We've got our first exam. So we do a review on Tuesday, and then we do the exam on Thursday, September 14th. So that's sort of the first thing to look to. And again, the schedule's there, so kind of plan out the test dates, plan out your study schedules, so you can kind of keep on pace with things. That's it. Attendance, again, I tend to fall back on my rule of skillful or not skillful. If you miss class, just make sure you're being skillful about it. And again, sometimes I needed to miss, sometimes you need a mental health day. It's actually better stay home and take a nap all day long or something. Sometimes we need to do those, and then it's better, right? And then we can make progress. But what we also have to do is, if I miss stuff at class, I got to be able to come back and get back on track with that. And so what I do is actually I'm doing it now. The reason I got this little thing in my ear is it's a noise canceling microphone, and so I'm recording the screen and my voice, and I will post each of our lectures into Canvas afterwards, so that it will allow you, if you missed, you'll be able to see what happened in class. If you were here, it also allows you to go back and maybe review something that you wasn't quite clear, or maybe you want to see it again, or maybe you're like me. I really have a hard time taking notes and learning at the same time. I could either focus on what the professor's saying, again, this is just my learning style, or I could take notes, but if I'm taking notes, it's like I'm not learning, I'm putting things on paper, then I got to go back and review the notes. So this is a way I came up with that actually worked for me, is I could sit through class and just listen, and then I could watch the video and take notes later, however it works. So I make those available to you to fit with your learning styles. Okay, so I'm not going to keep track of attendance. I should probably take attendance today, but again, that takes probably 10 minutes of time. And I'll ask, is anyone not here today? Okay, good, you got my humor. So yeah, if they're not here, how are they going to speak up, right? But it's up to you to be here in class, and that's really your being here is the first step. I think I try to make class as enjoyable as possible, make it beneficial for you, but when you do miss, again, the thing is how, be skillful about it, follow up, watch the video, and actually, as I'm going to show you in Canvas, because what I've done is I've taken a lot of the stuff I do for my online courses, you could actually even watch the video before class. Oh, I already know this stuff. Maybe I could not go and I could get the homework done in advance. That's being skillful. Okay. But then to be vindictive or punishing, oh, you weren't here in class, so I'm going to punish you, that's not good. Again, this is about learning, so find the way that works for you. But just keep me appraised of things that are going on. If something's happening and you're not going to be here for an extended period, if you can let me know in advance, we can work out things. Sometimes things happen and you can't contact me till later. That's fine, but communication is the best thing. Let's just work things out. Again, I'm not going to be vindictive. I'm going to be looking for what can we do to keep you successful. This happened. Okay, it's gone, the past is gone, but what can we do now going forward to keep you being successful in learning? Let's see, all this stuff. Do need access to Canvas, we'll get into that. There's messaging. There's the recitation. Now that one, again, you can't really do the recitation stuff outside of the recitation class. You have to be there enough. Although we will be dropping, I think it's in there somewhere. I think I can drop up to 2 of the recitations, but the recitation's about 20% of your grade. So you want to make sure you're there and interacting, and again, that's where you could do the group work. That's where you get the experience of communicating the mathematics and getting that benefit. If you're going to miss an exam, contact me in advance. Again, it's a lot easier to work things out, but do keep in touch with me. It won't make it worked out. Okay. No cell phones, no computers used On the exams, here's the layout. So in-class work, 5%. I don't know that we'll have a lot of that. Again, I'm just, most of it will be homework. The recitation's 20%. The exams are 65%. So there's 2 exams during the midterm exams, I guess we'll call them, and then 1 final exam. So that's a total of 65% from exams, 20% from the recitation. And the recitation should be set up pretty much if you're going there engaging, you should get all those points. The homework and the in-class work, those will probably be the same. I'll probably just do 15% for the homework. Again, if you get it all done, you'll get all those points. Okay, so and the goal is that as you learn, you do the homework, you're learning the types of things that are going to be on the exam. So those will help you do better on the exam as well. And of course, there's a grading scale, and we'll do our best to get you working up into the 90%. And then now we get into all this sort of policy stuff. There's tutoring available. There's a Math Tutor Center. There's my office hours. There's your recitation instructor. So there's times that you'll be able to ask questions in class. So we'll make that all work. Some deadlines as far as when to drop the class. But again, let's start off with this goal of we're all going to be successful. We're going to stay on track as much as we can. And when things happen, we'll make adjustments so that we can all still be successful. Yeah, and then again, you can read through all of this plagiarism, copyright. It's all just sort of university policy stuff. But again, if we apply those 2 rules, try to be skillful, try to be less unskillful, and try not to hurt anybody. Try not to hurt yourself, try not to hurt others. All this gets taken care of, right? We don't have to read all these details and legalities. We don't get in trouble. All right. Any questions? Yes, sir.
Where do you find this recorded lesson that you're talking about?
Good question. Okay.
Ironically.
So now I'm back into Canvas. Let's see. Let me get this a little bit bigger, and let me change it to Student View. So now this should be what you see. What you'll see is, so I've got Module 1, and I really just have the stuff for today because, again, I've got all the materials, but probably over the weekend I will set up next week. So today we're looking at 1.2 and 1.3. So I'll go into 1.2. What you'll see is I've got lecture slide deck, so that's what I'm going to use for the lecture. We'll get into that in a moment. There's some notes, and we use the same ones for the online course as for this course, so those are there. So maybe you don't have to take notes. You could print those out if you want, but the lecture kind of follows those notes. And then what I've got is, this is a video that I use for my online course. And again, it covers the same sections and stuff. What I will do is this video that I'm recording now, it will be up here at the top. So I'll put another link of recorded class lecture, something like that, right at the top. So you could click on that, and then you could see today's lecture. Again, it won't show up until the evening because I have to do some processing with it. Might be the next day before it shows up, but that's where it'll be. So it'll be by section. So 1.2 will have one. When we go into 1.3 today, I'll take a break and start a new video, so you'll see that. But you'll also be able to see that each one of these will have and they're numbered differently because the courses are set up a little differently, but the content is the same as the online content for Module 1. I have a Module 2 in the online, but I haven't, it's on domain and range, and I couldn't find where that was in this course. So that there's a few differences, yes.
Do the exams we take for each unit not count?
You're ahead of me. I don't know if there's exams for each of the units.
I mean,
Or,
I saw like the exam for September 14th. I thought like unit exam.
it's so I'm not. Yeah, it'll be however much we cover up to that time. So those will, yeah, that'll be about I think 20%. And then there'll be a second exam we take later on, about 2/3 through, and that'll be about 20% of your grade. And then we take the final exam, I think is 25%. So yeah, so those will get factored in that way. Yes?
Do the reviews also count for your grade, like the exam reviews?
We can. The other thing they allow us is a 1% extra credit. So we could certainly, and those are good things. That's why I like to use that 1%. So it'll certainly count for at least the extra credit. And maybe that's where I'll put the 5% in-class stuff. Maybe that's the reviews. So again, it gives some more motivation of not only am I doing something and learning something and getting ready for the exam, but I'm also earning some points and pad those things. So we'll do that. How does that sound good? Sort of the in-class stuff will be the exam reviews. All right. Good questions. But what you'll see is as I build this, there'll be there should be about one video for each section. Again, I may run into a section where I don't have a specific video, and I'm going to work to get a little bit ahead. So if I don't, I can make one. So there'll be kind of, if you want to watch the lecture beforehand, you could do that. It's a little bit more polished. And then we'll have the in-class portion, and I'll record that, which will be a little bit, you know, that's a chance for people to ask questions. And sometimes those are better because when I just sit down and explain it all myself, you know, I may have missed something. But when I do it in class and someone asks a question for clarification, then that makes it a little bit better, right? Because that might be the same question you had. And when I was just explaining it myself, I said, oh, yeah, everyone's going to understand this, right? Well, no, I forgot. I left something out or something. So we'll approach it from those ends. So there's a pre-recorded video, but then there'll also be today's video recorded. All right. Let's see, what time is it? So my goal will be to get done by 10, so that gives us a little bit of time if anyone has some questions at the end of class. We'll go through that. But let's go ahead and, if there are no further questions, go click on.
To access your Spotify data to do this.
Okay, I thought that was me. Usually my computer's talking back to me. So, okay, so if you click on that, it takes you to the slideshow. So this is going to be introduction to functions. Questions? Anything? Okay. So again, there's a pre-recorded version of this, but we'll kind of walk through it together as well. And this is, again, time for us to interact. So when we first start to talk about a function, we're going to use this word relation. What is a relation? What's a relationship? Two people. You can have a relationship with yourself, I guess. Hopefully a good one, right? But it's sort of a relationship takes two, so it takes yourself from two perspectives to... I talk to myself all the time, so yeah, I have a... In fact, that's the only way I know someone's listening is when I talk to myself. I know I'm listening to myself and not always the other way around. But relationship is two things coming together. So in math, the X is one part of that relationship. The Y is the other part. So there's an input. Some math is done to it, and it creates an output. Okay, so that gives us a relation. Now, all a relation needs is that the input gets matched with an output. There's no rule at all. But when we talk about a function... So a relationship between two or more sets of values. But a function is a special type of relationship. Function requires that each input can only have one output. So each x can only get matched up with one y. Now a y can have more than one x. So that's like the horizontal line. Everything is there. But each input can only have one output. That makes it a function. And again, things like circles we're going to see are not functions. They are relations. And we'll deal with that in trigonometry. But as far as algebraically, we consider that they're not functions, so we don't deal with them really algebraically anymore. So example of a relation that is a function. is that each input, over here is the input set, right? And you'll see that each one of them has only one arrow going to an output set. So we might call this the X and this the Y. This is the domain. And this is the range. And this is a function because each one of the inputs goes to only one output. Now, you might look at this and you see, well, look at this output number 5. It's got 2 values going to it, but that's okay. It's not. That's okay. It's only looking from the inputs can only have one output, so the arrows are going one direction. And so the domain are all the input values or the X values. The range are all the output values that are being used, and this is a function. Here's an example of something that's not a function. And can you see which value causes this not to be a function? We can see -4. It's going to 2 different y values. So it's playing the field, So that's not okay. It's okay for the y to have 2 x's going to it, but each x can only go to one y. So this is not a function. And again, what we do with this is once we've determined something's not a function in our algebra portion, we say, okay, we're not dealing with it, because everything we deal with is going to be a function. Okay, so I don't know why we spend so much time figuring out whether it's a function or not, but it's part of it is if it's not a function, we don't deal with it. And part of the way we can look at that is if we graph it, this -4 would have 2 output values, and so we call this the vertical line test, that if we draw a vertical line, it goes through 2 points. That's another way to determine this is not a function. So that's why something like a circle is not a function. If you draw a vertical line through, it'll hit it in 2 places, that you're getting two outputs for that one input, one X input. Okay, so that's just being able to identify, is it a function or not? So there'll be questions like that that you'll deal with. We can use this thing called the vertical line test. If the vertical line touches the graph in 2 places, 2 points, then it's not a function, 2 or more. And it only has to happen one place. Now, what if we were to take this -4 out? So, okay, let's get rid of it. Now is it a function? If we only had these three points in the domain, we erase these, then it will pass the vertical line test because each would only go through one. So there was just that one point that's causing this to not be a function. We could take it out, and now it's a function. And we'll do that with some of the things. So we do things like a quadratic function. If you were to actually look at the square root function, it's actually not a function because it's basically the quadratic, the parabola on its side. But what we do is we only look at the positive values, so we cut off part of it, and that's how we make it into a function. Okay, so we do a few tricks that allow us to look at things as functions. Okay, that would otherwise not be functions. So that's the idea is, okay, that -4 is causing us problems, let's just throw it out. Now we got a function. So sometimes we'll do that. Vertical line test, we already talked about this sort of in advance, but just think of it. If I draw a vertical line, and if it touches that graph at 2 points or more, then that's indicating it's not that's not a function, right? So we talked about that. So one way to determine whether a function is, where expression is a function or not, an equation, is to solve for y. So if we can solve that y equals one thing, then we'll have a function. But notice what we'll do is we'll walk through this, if we're going to solve for y, what do we have to do? What do we have to do with this x squared? So get x to the other side, which kind of subtracting x squared from both sides. So that gives us y squared equals 9 minus x squared, which is okay. But this is not solved for y yet. How would we solve for y? Square root of both sides. And does anyone remember when you take a square root of something that's squared, what does that introduce? A plus or minus, because when you square something, a negative squared is positive and a positive squared is... So it's sort of abstract, but you have to remember that that's when we're doing this process, it introduces a plus or minus. And so what's going to happen is for any x value that I put in here, I'm going to get both a plus and a minus output value. So I've got each x value is going to how many y values? 2. A positive and a negative. Is this a function? No. And again, if you were to graph this, what you'll see is this is a graph of a circle with a radius of 3, square root of 9 is 3. And we'll deal with this in trigonometry, but again, we don't deal with this as algebra anymore. Actually, when I was going to school, we did. We started this was the first part of algebra classes. We did the algebra of circles because we were not restricted to just functions. But somewhere along the line in the 90s, they decided that when we teach math, it's all going to be about functions. So that came into play. So this is not a function. Cool thing is I like to use the Desmos calculator because it'll actually graph this. So another way to look at this, I'll just click here. Again, we can't use this on the exams because it's a computer based and you've got internet and all that kind of stuff. But you could look at this. What was it? It was x squared plus y squared equals 9, and you see a circle. And now I can do this without the algebra. I could say, oh, that graph, would that pass the vertical line test? Nope, it's not a function. So here's another way to do it. And Desmos is nice. We're getting better graphing tools, which again, for engineers, that's the primary way you do math is using the technology. That's what engineering companies want to see. They want to see run through the technology that's going to be able to do things like this. All right. Oops. So some of the things we do is we're asked to evaluate a function. So once we do have a function, so an evaluation is we're given come back here. We're given an x value, and so we want to again do the mathematics. Now you can do this by hand like I'm doing, plugging it in here. You can also use your graphing calculator, looking at the table of values, multiple ways you can do it. But that's what that means, and then do the math and come up with an answer. So we get 2, negative 5 squared is going to be 25. Negative and negative are going to be positive. That'll be 30. So I get 50 plus 30, that must be 83. So there's an example. You'll be asked to do that. You're also going to be asked to evaluate where you're given another variable. So for this one, we do the same thing, but what we're going to plug in is the variable t plus 1. And then we follow through with the math and not solve, but we simplify, right? So we're going to have to FOIL this out. How are we doing on? I've got about 15. So I'm going to let you, again, in the video, I actually work through each of these, but I just want to kind of give an introduction today to get you started. And if you want to see the details of actually working through that, go ahead and watch the recorded video. I think it's about 45 minutes. And again, you could fast forward to that. This one means if we're going to put x plus x over 4, we're replacing the x. So one of the things I do when I evaluate is sort of the first step I take is I rewrite the function that I'm given. I rewrite the x's as being open parentheses, because isn't that a nicer place to plug things in, right? A nice open parentheses. If I've got an x, it's kind of a closed thing. And the other thing is psychologically, it's really hard to put something that has an x in for another x, so an x over 4, and I'm putting that in for x. It doesn't explain to me how that makes sense. It doesn't. It doesn't. But if you just look at x, when I taught at Oregon State, one of my students said, it's like X is on a treasure map, it marks a spot. And that's exactly where I came up with this is, you're right, X is just marking a spot. So let's just put that spot. And it just made it a lot easier. So I rewrite it this way. And so what goes in that parentheses? Whatever's in here. So I'm not having to say, oh, I'm putting X over 4 in for X, because that, again, my mind just doesn't accept that. But here, it just says, what's inside the parentheses? X over 4. X over 4. And now I can just do mathematics to simplify that out, square it and go forth. And I don't have to go through the psychological challenge of putting X over 4 in for X, and that because my mind's saying that's not right. X is X and X over 4 is X over 4, and how is it? But what it is, it's really the function we're given as a template. Okay, we okay with that so far? And again, feel free to speak out if you've got questions. I'm here for you, so we'll work through that. A piecewise function, this is oftentimes causes the most confusion. Part of it is because the way we're given it, you have to read it sort of backwards. And when I studied mathematics, I did a lot from the cultural aspects. Algebra, the word algebra, does anyone know what language the word algebra comes from? Algebra.
Arabic.
It's Arabic. I studied Arabic for a year, mainly because of that. I had some friends, Egyptian, Saudi Arabian, played on a soccer team with them and was interested. But the thing that really interested me about Arabic was that it was written in the reverse direction, right? It's written from, and I'm dyslexic, so it was actually, for me, it was better because I can write with my left hand, and I write Arabic with my left hand. At least I could. It's been like 30 years. Algebra comes from the Arabic, so when in Arabic they were writing, is that right to left? And so a lot of the times is when the Europeans got the algebra concepts, they didn't quite understand them, so they just wrote them how the Arabs had them written. But now they're reading them in the wrong direction. So if you've ever struggled with the algebra part, it's probably because you're reading it from an English mindset and you're reading it from left to right, when you should actually, if you read it from right to left, it would make so much more sense. And so this is one of those things, if you read a piecewise function from right to left, so we're going to go this way, then it makes sense. Because what you really need to do here with a piecewise function is determine what each piece is getting used for. So this part here, on the right-hand side, if we read this way, this is the domain. So this is telling us whenever x is less than or equal to -1, that the function is going to be y equals 2. And that's what I'll do. It's just really a function y equals 2, or f of x equals 2. And then if x happens to be bigger than -1 but less than 2, if that's its domain, then the function is y equals all this stuff. Okay. And then finally, if x is a value that's bigger than 2, if that's what it is, then I use this third part. So that's really the part we have to look at first. But as English speakers, we're so used to reading it from left to right, we're reading it backwards from how it was intended to be done. So that's the cultural aspect of mathematics, is our math comes from various regions. When we get to trigonometry, trigonometry is a mathematics that comes from the Babylonians and the Greeks, but it's sort of another different culture. The Babylonians had a base 60 number system. The Arabs studied in India, and so they used the Hindu Arabic system, which is a base 10 system. So all the numbers all work. Okay. So if we're finding f of negative 3, we look over here. Oh, negative 3 is less than 1. We use this. Our answer is simply going to be 2. F equals negative 1. Well, that's also because this one says x less than or equal to negative 1. So for this one, I also use this first piece. Okay, so let's see how it works. Is just, okay, what is the x value? Which piece do I use? So this one, the answer also is 2. When x is 0, oh, that's this middle piece, because 0 is bigger than negative 1 but less than 2. So then I've got to take this thing here, and for x I put in 0. And so I take 1 and I square it as 1, and then I put a negative on it, and my answer ends up being 0. So f of 0 is 0. But that's how I work a piecewise function, is figure out which piece I'm going to use first. But again, the confusing part is if we're reading it the way we read English, we're reading it backwards, because culturally it was done the other way. We can also evaluate a graph. If we're given an x value, what we do is we go to where x equals 3. There it is. We go till we hit the graph, and our answer is going to be what the y value is. So evaluate at x equals 3. That's going to tell us y equals negative 2. Find x when f of x equals negative 1. So negative 1, what is this? This is a y value. So we're looking when y is negative 1. We go to the graph. We hit it here. But we also hit it here, don't we? So when we have a y value, it is possible that we're going to get two x values. And in this case, we actually do. We get two answers. We get x equals 2 and x equals 4. Okay, so that's part of what's in the homework too. We'll go with this one. I'll tell you what, we're going to go with this one, and then 10.13. If you want to get on it, you can watch the video. Otherwise, and either way, next Tuesday we'll take a look at 10.3 and 10.6 together. But I think this one is good enough for us to go through because it's in the homework. Okay, so the difference quotient is this thing. Does anyone know what what the difference quotient comes from? Is that? Someone say slope? You said slope, you're right. So this really is 2 points. So there's a point x plus h and a point x. So notice x plus h is the point x moved a little bit. And so this is going to have a y value of f of x plus h. And this one is going to just have a y value of f of x. So that's our 2 points. And if you remember, the slope function is really just y2 minus y1 over x2 minus x1. So what this really is it's f of x plus h. That's one y value minus f of x. What's the x value that goes with x plus h? X plus h. What's the x value that goes with f of x? X. And notice you get x minus x, which is 0. And so that's why you got the h. But when they show it in its simplified form, it doesn't look like a slope function, does it? Or formula. You don't see two x's down here. You just see maybe two y values, y2 minus y1. But this was x2 minus x1, but the x's canceled out. Okay, so that's what we're doing. So what this is, and I'm spending a little bit of time here because this is the foundation for calculus. This is what we use for calculus. What calculus is going to do for us is we're going to be able to get actually the slope at a point. But we don't get to that in this class. We're going to use algebra. So what in algebra we're doing is we're using 2 points. We're using x, xy, and then a little bit of distance away. But we use that variable h so that we can make h smaller and smaller until the 2 points become 1. And we're going to see that what that gives us is a tangent line, and that's what we call the derivative. That gets us into calculus. So this is a foundation of calculus. But you have to see that what this difference quotient is, it's just the slope. It's a slope of 2 points, and what we're doing is we're labeling the points such that we can take the second point and we can get it closer and closer to the first point and make them the same one. And that gives us instantaneous rate of change, and that's a powerful mathematics for engineering or anything else. So, but what we end up doing is if this is f of x, right, what is f of x plus h? Well, that would be 7x minus 7, right? I just changed the x into a big parentheses. What do I put in that parentheses? X plus h. And so then I can simplify this a little bit, distribute the 7, so I get 7x plus 7h minus 7. So that's what f of x plus h is. Now what I'm going to do is just use this sort of as a template. I'm going to replace f of x plus h with this statement. Right? So that is f of x plus h. And then I'm going to subtract. Now be careful here. F of x, I'm going to put a parentheses. What is f of x? 7x minus 7. And if you don't put those parentheses, you might just apply the negative to the first term, but that this negative here has to distribute. And again, this is all over h. And so then we're going to distribute this through. So we get 7x plus 7h minus 7 minus 7x plus 7 all over h. And then you'll see that the 7x is positive here but negative there, so those cancel out. We've got a negative 7 and a positive 7. That becomes 0. And we simply have 7h over h. And what happens to the h's? They cancel, they become 1, so that's 7. And so what we did is we used this slope formula that this, and we're going to see when you get to calculus that the derivative of this function is actually just 7. That we actually got the derivative of it. It's going to be, and if you think of it, right, it's a linear equation. Isn't the slope of a linear equation the number in front of the x? 7x, so that's our slope.
Sometimes these problems tend to get harder, so you know you're doing it right when everything starts to cancel out.
Yes, you'll always get that canceling out.
So if
Very
I
good.
don't get them canceled out, I know something's wrong.
Yeah. We're going to give you the harder one. So I took the easy one as a linear equation. If we gave you a quadratic, you've got to square things out. That's the one that gets messy. Cubics are terrible. We won't give you those. But quadratics, they do get messy, but you're right. Make sure things are canceling out because that's how it's developed, right? You take this function and this function and this function. They're very similar, but this one is x plus h. So most of the parts will cancel out. There's a little bit left over, and what that gives us is what's the derivative. So we're actually on the cusp of doing some calculus right here. And now it's time to do homework. Now you'll see in my things I talk about online tutoring. So we don't have that because this is not the online class. So the online classes have different resources. But so bear with me. I'm kind of in between the online and the in-person version. But that's how it'll work. So what we'll do is we'll look at 10.3 on Tuesday. Although if you want to get ahead, you can watch that video and it's all there.
Is the difference quotient just a shorter way to make, like, to find the derivative? And easier?
Exactly. It's where we start with the derivative. And you'll spend almost a week or sometimes 2 weeks on it, and you'll get so frustrated, and then you'll learn all the shortcuts, and it's a lot easier to get that this way. But this is the technical way to that sort of says that, yes, we are getting a slope. So we do that here. When you get to your calculus class, again, you'll spend a whole nother week at it, but just kind of bear through it. This is the part where I almost got lost and just was going to drop everything. Someone said, just hold on. There's going to be easier ways to do it. And you find shortcuts, and then you never have to use this again. So it's kind of like, get you there. Okay? Questions? All right. Nobody left. Nobody, especially no one went screaming out, so that's always good. I'm looking forward to working with you, making things successful. Again, the biggest thing is communicate. If you need anything, let me know. If I irritate you in some way, let me know, and I'll try not to do that because I don't want to irritate anybody either. But let's work together, and we'll see you next Tuesday. And again, no recitations this week. They all start next week. You don't. It's canceled. Yeah, so they told us not today. So our TA contacted me last night. She wasn't even sure. I said, no, I was told no recitations this week.
I checked the assignments on the Houston MyLab. We don't have to start those just yet, do we?
No, because I always put the due dates like a week out. You could start on it, but you don't have to. Yes.
Thank you, sir.
So I just want to talk to you about in the future. So I'm in the Army, and so like, one week in a month, I'll have to go to my unit. I don't have a schedule.